in this project, you're going to put together the two pieces of software you've developed so far. You're going to connect your hillclimber, which you wrote in Python, with your robot simulation that you created in Bullet in C. Remember that in the hillclimber, we have a parent which encodes the synaptic weight matrix, or the set of all of the weights for all of the synapses for a given neural network. And now, instead of evaluating the neural network in Python, we're going to send this using a text file. We're going to write out a text file that contains all of the numbers in this synaptic weight matrix. And we're then going to read it in to our Bullet code. And we're going to use all of these synaptic weights to label or set the weights of the synapses in the neural network that controls our robot, which, as you'll recall, is made up of 4 sensor neurons and 8 motor neurons. This particular neural network is now going to control your robot, and your robot is going to move a certain distance away from the origin. We're going to measure that distance, and we're going to write out that distance in another file. And in that file, we're just going to have a single number. In this case, let's imagine that our robot moved 8.2 units away from the origin, and our Python code, or our hillclimber, is going to read in that number, and that is going to become the fitness of the parent synaptic weight matrix. Remember now that the hillclimber creates a child, which is a new synaptic weight matrix. This is the child. And when we copy the parent into the child, we introduce some random mutation. And now we're going to write out this new synaptic weight matrix to a text file. Synaptic weight matrix, and I'll just indicate it with a prime to indicate it's slightly different from the original synaptic weight matrix, which now creates a slightly different neural network in our Bullet simulation, which causes our robot to move in a different way. We're going to again record how far the robot moved away from the origin. We're going to write that out to a text file, and maybe in this case, the child synaptic weight matrix caused the robot to only move 6.2 units away from the origin, compared to the parent, which caused the robot to move 8.2 units away. So the fitness of the child is only 6.2. This is lower than 8.2, so we delete the child, and the parent makes another child, and we continue. And if we continue this process long enough, we will eventually evolve a neural network that causes the robot to move a far distance away from the origin.